A uniform chain of length L is placed on a rough table with its length L by N such that N greater than 1 hanging over the edge of the table. If the chain just begins to slide off the table by itself, the coefficient of friction between the chain and the table is. Solution. Here is the given rough table, say. Now the chain is placed on the table so that a portion of the chain is suspended from an edge. It's given that the suspended length is L by N and the remaining length on the table is obviously L minus L by N. Here the suspended length causes a pull on the chain and there exists a friction between the chain on the table and the table, and that friction opposes the pull. And here is the normal reaction exerted by the table on the chain, that is N. Now for limiting equilibrium, that is when the chain just tends to begin its sliding, what we call as limiting equilibrium. For limiting equilibrium of a chain, pull due to the suspended portion is equal to friction. Therefore M suspended, that mass suspended, into G is equal to mu into normal reaction. Here normal reaction is M on table, that mass of length of chain on table, into G. Now to get the value of the mass of the chain suspended, let us say now a condition like this. If K is mass per unit length of chain, then here M suspended is, here K is mass per unit length into length, that is L by N. K is mass per unit length into the length, that is L by N, into G is equal to, here mu into, here M on table is K into, here the length on the table is L minus L by N, into G. So now here G is cancelling, K also is cancelled, and one L also cancelled. Therefore 1 by N is equal to mu into 1 minus 1 by N. Therefore mu is equal to 1 minus N by 1, that remains. Therefore option B is the correct answer.